In this video, we'll be talking about factorials, combinations, and permutations, and specifically we're talking about how to do these on the TI-84. So I have a question for you. The first question goes like this. How many unique lineups, let's say I'm the coach of a Little League baseball team, and every single player on the team can play any position, I can bat them in any order, it doesn't matter. How many unique lineups can I be set if I have 15 kids on my roster and I'm going to play 9 at a time? Well, the first thing I need to decide is, does the order matter? And what we know is this: if we're talking about setting a lineup, that means that the order does make a difference, because if I bat a kid first versus ninth and everybody else stays the same, yeah, those are different things. And so the first thing that I understand is that order does matter, and that means that this is a permutation problem. So really what I'm saying is I have a group of 15 kids, and I want to be able to select 9 of them at a time. The formula then goes like this. I'm going to use NPR, which means that I'm going to take 15 factorial over 15 minus 9 factorial. So let's learn how to do this on the TI-84, because really what this is saying is I've got 15 times 14 times 13 times 12 times 11 times all the way down to 1. And then on this side, I have 15 minus 9. Well, that's 6. So I have 6 times 5 times 4 times 3 times 2 times 1 on the bottom. That's a lot of multiplication. There's got to be an easier way, right? So what I'm going to do is I'm going to concentrate on the math menu right here. I'm going to start off by typing the total number that I have. I have 15 kids. I'm going to go to math, and then I'm going to go over to the probabilities menu, and you'll see that we have our factorial key here. So I hit enter. 15 factorial divided by 6, I go back to math, go to probabilities, and I choose this, 15 factorial over 6 factorial, and that gives me a huge number. In fact, let's see, that has 1, 2, 3, that is 1,816,214, 1,000. Wow, can't even read my numbers. 1,816,214,400 ways that I could rearrange those 15 kids into unique lineups. That's a lot. Now, if you don't know how to use the formula, let's say you get a test day or you're in the ACT and you don't know how to do this, you can't remember this formula, easier way is to simply do this. 15 kids, math, probability menu, and you might have noticed that we scrolled by NPR. 15 permutations, taken 9 kids at a time. And it turns out it gets us the exact same number. 1,816,214,400 ways. Now, different problem then. Let's say that I go to get a puppy, and I show up, and there's 7 puppies in this litter. And then all of a sudden my mom says, hey, you know what, I'll let you take 3 of those puppies home because they're so gosh darn cute. How many ways can I choose 3 puppies to take home out of a litter of 7? How many unique ways can I do it? Well, in this case, if you pick 3 dogs, it doesn't matter which one you choose first. Those 3 dogs, it doesn't matter, the order does not matter, because I'm going to end up with those same 3 dogs no matter what. So because order doesn't matter, that means that I have a combination problem. Well, on the TI-84, you could probably guess how to do this. All I need to do is this. I have a group of 7 things. I want to find the combination, because order doesn't matter. The combination, the way to take those 3 at a time. So I come to my calculator. I go 7, math, probability menu, NCR, 7 things taken 3 at a time. It turns out there are 35 possible combinations of puppies that I could choose to take home. Pretty simple.